Hello, this is Adele here at the Sea Science Center again with another feature of our LEGO Millyard Project. This is the Notre Dame Bridge. It's kind of an icon here in Manchester. It was torn down in the 1980s, but everyone remembers it. But this bridge wasn't actually here when the Amoskeag Company was making textiles here. In 1936, the Amoskeag Company was struggling financially, as it was during the Great Depression. And there was a huge flood that flooded into the first floor of many of the buildings. So after the flood, the company was not able to reorganize and reopen. So that represented the end of the Amoskeag Manufacturing Company. The flood also washed away the bridge. And this bridge was built to replace it. This was a steel bridge, and it was built exactly the way this Lego one was built. You can see there are no supports underneath. Volunteer Teddy Welsh actually designed and built this bridge based on the engineering of the actual bridge.
I'm standing in what would be the Merrimack River, and I'm right in front of the Notre Dame Bridge, which is a truss bridge, and it's constructed of a whole bunch of triangles. There's a lot of mathematics in this bridge. When I designed this bridge using a spreadsheet program, I had to fiddle around with how long each one of the different beams would be. And as it turns out, all of these different beams, the diagonal ones, the vertical ones, as well as the ones that make up the main arch itself, they're all slightly different lengths. So I had to try out, basically trial and error, and use a computer program to figure out what the different lengths would get us in terms of shape. And what we ended up with is what you see right here. So if you ever have a chance to take a trigonometry class, you're going to learn the mathematics that was used in figuring out how to put this bridge together. Of course, there's a lot more than mathematics in this bridge. There's a lot of engineering. So the main arch itself, you'll notice, is made out of very thick beams. They're very strong, they're very sturdy, and this arch holds the weight of the entire bridge and all the traffic passing across it. Now, the small beams that hold the actual surface of the road itself, that carry that weight, don't need to be quite as big because each one of those is only carrying a small portion of the weight. You can also see some engineering in the three different kinds of triangles. There are the main triangles that you see in the main truss design. There are also some triangles on the inside of the bridge that are made out of wire. It keeps the bridge from tilting over and falling into the river. Then there's a third kind of triangle on the top of the bridge. It looks like a whole bunch of V's coming down the top of this bridge, and that keeps the bridge from wiggling back and forth. I was really impressed when I was putting this display together that as we added each kind of triangle, the bridge got sturdier and sturdier and sturdier. The bridge was designed and built off-site. So we did the actual building at the LEGO headquarters in Enfield, Connecticut. And another fun thing is that there's no piece that actually holds this thing together that's longer than 8 studs long. It's all consisting of sandwiches, and that was a limitation of the color, that we wanted to use this light green color, and the longest that we can get in that color is 8 studs long. So we did a whole lot of overlapping of different pieces on top of each other, and when you make a sandwich that has a bunch of layers, you can make something pretty long and pretty sturdy, and that's exactly what we ended up with.
A great challenge is to try to build a bridge yourself. Whether you use Lego bricks or cardboard or popsicle sticks, you can try to build a bridge at home using different engineering techniques and put weight on it and see how strong it is. I hope you like this look at the Notre Dame Bridge here at the LEGO Millyard Project. See you next time.